Alrighty guys, this is part 3 of lesson 29. I'm on page 623 and I'm going to do number 1 with you guys. So it says Mary has a board that is 7 feet long. Okay, she cuts off 1/4 of a foot of the board to make an even edge. So she had to cut off 1/4 of a foot. Then Mary cuts the remaining board into 3 pieces that are the same length. So we know they're equal. How long in feet is each piece? So each of these 3 pieces. So I'm going to draw kind of a number line. Okay. Going as straight as I possibly can. We're going to start at 0, obviously, and then we're going to end at 7 because she said it's 7 feet long. Okay, and then I know it says she cuts off 1/4, so I'm going to break up each of the whole numbers into fourths. So I need to go from 0 to 1, so I'm just going to do whole numbers first. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Not really perfect, but it's fine. So now in between each whole number, I'm going to break them into fourths. Okay, so we have 6 and 1/4, 6 and 2/4, 6 and 3/4, and then 7. So if she cuts off 1/4 of a foot, I'm just going back. Each of these tick marks takes me 1/4. Okay, so I'm going to take off from here. I'm going to use a different color. From here to here. That's her 1/4. Remember, when we subtract on a number line, we always move to the left. So we're going from 7 to this tick mark. And this tick mark right here is 6 and 1/4, 2/4. This is 6 and 3/4. So that's how long her board is now. So I know it's 6 and 3/4 feet. Okay? And she's breaking it into now 3 pieces. So I need to figure out how many times I need to divide this by 3. So I know 6 divided by 3. What is 6 divided by 3? Okay, ask yourself that. What's 6 divided by 3? I know that that is 2. And then 3. So I have 3/4. So I have 1/4, 2/4. So let's say this is 0. 1/4, 2/4, and then 3/4. I need to break this up into 3 parts. So what would that be equally? Each 2, 3 is 1/4. So if I'm dividing that by 3, I know 1/4. So each piece is 2 and 1/4 feet. Okay? Let's look at number 5. Four friends pick small pumpkins at a pumpkin patch. So there's 4 of them. The table below shows the weight of each pumpkin. So Kelly's was 2 pounds 9 ounces. Neelan was 30 ounces. Jackson was 2.5 pounds. Raul was 38 ounces. So order the weights of the pumpkins in ounces from least to greatest. So smallest to biggest, okay? How many ounces are in a pound, guys? We have to know that. So I'm going to have to Google that. How many ounces? See, even your teacher doesn't have this memorized, so it's okay if you don't either. So there are 16 ounces in 1 pound. Okay, so I'm going to get my whiteboard. I know Kelly has hers in pounds and ounces. So if I know 1 pound is 16 ounces, how many pounds or how many ounces is 2 pounds? I'm not going to put my ounces because I don't need to convert that. So I just multiply diagonally, 16 times 2. I know 16 can be decomposed as 10 plus 6 times 2. and that gives me 20 and 12. 20 plus 12 gives me 32. So 32 ounces plus Kelly's 9 other ounces. That gives me 41 ounces. So I'm going to write right here, 41 ounces. Okay, I already have 30 ounces. And then I have 2.5 pounds. So again, I know 1 pound is equal to 16 ounces. How much would 2.5 pounds be? Okay, multiply diagonally. I already know 16 times 2 is 32. And what's half of 16? That would be 8. 32, 8, 10, 40. So 40 ounces. Okay, I'm going to write 40 ounces right here. And then the other one we don't need to convert because it's already 8 ounces. So from least to greatest. So I have 41, 30, 40, 38. So the smallest one would be Neelam's, which is 30 ounces. Okay, then the next one would be Raul's, which is 38 ounces. And then 40 ounces, which is Jackson's. And then the last one, the greatest weight, would be Kelly's, which was 41 ounces. Okay? Let's look at number 6. Tara has a 5-liter container of water. She pours 3 liters of the water into a pitcher. She pours the rest of the water into 8 glasses so that each glass has an equal amount of water. How many milliliters of water does Tara pour into each glass? Okay, lots of steps in this one. So if she starts with 5 and then she pours 3 liters. So I need to subtract. So now she has 2 liters left. Okay? So she pours the rest of the water. So here's the rest of the water, 2 liters. She pours the rest of the water into 8 glasses so that each glass has an equal amount of water. So I need to get it in milliliters, okay? So 1 liter is equal to 1,000 milliliters, okay? So how much milliliters would 2 liters be? Multiply diagonally. 2 times 1,000 would give me 2,000 milliliters, okay? And she has to pour equally into 8 glasses. So all I'm going to do is 8 into 2,000. Okay? I know 8 can't go into 2. Can it go into 20? Yes. 8 times 3 would be 24. That's too big. 8 times 2 is 16. So let's do 200. So I know 8 times 2 is 16. Add 2 zeros. Subtract. So I have 400. I know 8 times 5 is 40. So I'm going to do 8 times 50. 8 times 5 is 40. Add my other 0. And I get 0. So I'm just going to add 250. And that answer is B. 250 milliliters. Okay, one more. Let's look at number 7 on page 626. A parking lot is 316 feet long. Workers paint lines to make 1 row of parking spaces. They do not paint lines on a 28-foot length. They do not paint lines on a 28-foot length at one end of the row in order to allow cars room to park. Oh, so they need a gap of 28 feet because if you had a parking lot, let's just make sense of this problem. So if I had a parking lot and I went, okay, parking lot, these are all parking spaces, and I did it all the way to the border. Okay, so let's say these are all the minimum amount of space that a car needs to park. Let's say a car's parked here. Not a very good car. Okay? And then there's a car here, a car here, car here, car here, car here, car here, and a car here. How is this car going to get out? They're stuck. Okay? So that's why they say they need that 28-foot length at one end of the row in order to allow cars room to turn. Okay? The workers paint lines along the rest of the row to make 9-foot wide parking spaces. How many parking spaces does the parking lot have? Show your work. Okay, so if I know that they have 316 feet total, okay, that's what they said they have. That's how long it is. But they also need to take away our 28 feet for room to turn. Okay, so I'm going to subtract, and I get 288 feet, okay? And now I know I need to have 9-foot parking spaces. So I need to figure out how many parking spaces can I fit. So that means I need to divide by those 9 feet. So I'm going to go 9 into 288. Okay? 9 can't go into 2, but it can go into 28. So 9 times 3 is 27. So I'm going to do 9 times 30. 9 times 3 is 27. Add my 0. Subtract. 8. 1. 18. 9 times 2 is 18. And 0. Add them up. So how many parking spaces will there be? And that is 32 parking spaces.